Welcome to the SBGrid YouTube channel. Software tutorials by developers, lectures by structural biologists, unique content brought to you by SBGrid.
So today I'm happy to introduce Thomas Stewart from Schrödinger, who's one of the PyMOL developers. He's actually number 3 on PyMOL GitHub if you're interested in those kinds of stars. And today he's going to be talking to us about the visual presets in PyMOL 3, and we'll be doing a demo afterwards. If you have questions, you can send them to us in chat, and we will please hold them till the end. We should have time for Q&A. And with that, Thomas, once again, thank you, and the show is yours.
All right, give me 1 second.
Sure thing. All right.
Cool. Can you guys
slides
see my
look
slides
good
now? All right, awesome. Thank you very much for the introduction. As he said, I am Thomas Stewart. I'm one of the PyMOL developers here at Schrödinger. I've been working on PyMOL for almost 2 years now, which is kind of crazy. What a 2 years it's been. But yeah, so today I'm going to be introducing you to the presets panel. It's one of the major features that's going to be in the upcoming PyMOL 3.0 release. We're hoping to make it a big one and actually pretty impactful. And I'm going to be showing off, like I said, one component of that today. So just to get started, I'm sure many of you are familiar with PyMOL, but just in case anyone isn't, I want to introduce the idea of what PyMOL is. So PyMOL is a very powerful visualization tool that has been around for, I guess, decades at this point. But it's used to create high quality images for publication, really cool movies, and otherwise show off biochemical structures in a very compelling way, in my opinion. In addition to it being used for publications, it's also a great learning platform. I don't know, I'm sure I'm speaking to an audience of many people that have been involved in structural biology for a number of years, but the point where structural biology and protein structures really became compelling to me personally was when I first got to see them in 3D, which happened to be in PyMOL. I feel like, you know, in your introductory biochemistry classes, you learn about protein structure and primary, tertiary, all of that stuff, but it doesn't really become compelling until you can literally see the structure and play around with it and move it and, you know, see some of the intricacies that aren't obvious initially. So it's awesome for a learning platform in that sense. PyMOL is also unique in that we have kind of 2 different components. So we have both our open source and our incentive versions of the software under the same PyMOL umbrella. The open source has the advantage of having a very solid, active, and willing to help community that surrounds it. We have a very active mailing list and forums where people are constantly asking for help and receiving it, you know, not even just from our developers, but from other people in the community. And then we also offer incentive software that has some really, really powerful improved capabilities that we've worked really, really hard on. And that's one of which I'm going to be previewing today. But not only do we have these awesome features, but it also provides integration into the larger Schrödinger suite. I'm not trying to sell the whole suite to you today, but just mentioning some of the differences between the 2. So I'm just going to quickly show you some images from PyMOL that I've made personally, just to kind of show what PyMOL is capable of. Like I said, I'm sure many of you have already used PyMOL or are familiar with its capabilities, but for instance, this is actually my personal favorite protein. I don't know, it sounds nerdy to say aloud, but this is a protein from my undergrad research. It's actually a peptide inhibitor of the Cas9 protein from CRISPR. But why I'm showing you this, it provides kind of 3 different elements that I think are compelling in protein structures in general, PyMOL. Showing the RNA, showing a larger protein, a smaller protein, how they interact. And I'm going to be using this later in my demo, but I'm just showing off some of the cool images that can be created up front here. another cool image. So this actually is demonstrating a couple things. First of all, this is made using our DNA builder. So you're able to input a sequence and create a DNA structure off of it, or RNA structure in this case. This is actually the first, I don't know, 50 or so residues of the mRNA vaccine for COVID. So when I made this was obviously more topical. I guess it is still topical, but it was just cool to be able to take the sequence, throw it in PyMOL, and create an actual image showing what the structure of this vaccine might kind of look like. I know it's not representative, but just to show you what PyMOL can do. Whoa, sorry, I just skipped through all my slides all of a sudden. But even beyond that, I mean, the two structures I just showed you, or two images, are very typical PyMOL images, right? It's what you would expect when you load in a protein structure, and all of us have seen those kind of images before. But in this case, this is a completely different style within PyMOL. Looks completely different, and it is made entirely in PyMOL, right? So these more complicated stylings, people often don't invest the time into learning all the settings and all the options and create some incredibly complicated script to make something that looks as cool as this. That's going to be part of what we're trying to address today. This is another example. This is one of my absolute favorite images I've made in PyMOL. It's not very technically relevant maybe, but I think it looks really, really cool and compelling. This is actually the same structure I showed you before, that peptide inhibitor of Cas9. It looks so cool though. It looks like little nerd candies or something. But again, what I'm trying to demonstrate here is the variation of representation and styling that you can actually create within PyMOL that may not be initially obvious, or people may not be aware is even possible. So after showing all those images and kind of giving you a sense of what PyMOL can do, I want to talk about presets. So many of you may already be familiar with how presets work in PyMOL. I'll give a demonstration of how they work currently and what we're trying to work on. But essentially, you are able to pick from a pretty limited list of presets for styling and visual representations within PyMOL. It's very limited in terms of its scope and the number of presets you can pick from, but it is very easy to use, right? So you click a single button and you get a uniquely stylized protein. The second bullet point here might be controversial, but in my opinion, a lot of the presets are outdated. These presets have been around for the better part of 2 decades. And I think the field has come a ways since then, particularly just in terms of what's possible and what's expected in representing some of these structures. And the last bullet point here is that they're not very specific and not very informative or technically oriented, because there's a limited selection of presets that you can pick from, right? So if we're going to give you 8 or 10 presets to pick from, they really can't be specialized in any meaningful way, right? So our main goals for revisiting these presets are that we make it easy to use them. We don't want to make it more complicated or more daunting. But on the flip side of that, we want to make sure that they're both easy to use on the front end, but for our power users or people that have very particular styles that they want to achieve, that they are empowered to use those settings and more complicated scripting type stuff that allows them to create really, really good looking images and representations. And the last bullet point here is that we want presets to serve as a starting point. And what I mean by that, there's kind of 2 separate components within that. The first component is that we want you to have a preset as part of your workflow, that when you load in structures, they are loaded in, or you can apply a preset that puts it in a form that is useful to you, right? So the example that I keep going back to, like, let's say your lab is very focused on membrane proteins, right? That's your whole, your entire lab's focuses on membrane proteins, or something similar. There may be a very particular way that you want those membrane proteins loaded in, because as I'm sure we all know, there's certain like regions within membrane proteins, or maybe just the membrane itself you want represented in a certain way every time. So that's kind of the first component, is like in your workflow, having a preset that is just your default load in starting point before you do any other additional styling or changes. The other component of this starting point is that they are able to be consistent. So going back to our lab example, let's say that, you know, for your lab presentations in your membrane protein lab, you want everyone to have the same styling so that it's easier to tell differences between the different structures that you're going to be seeing that day, right? So currently, I mean, people have all different ways of showing their proteins, but it would be much easier to tell the difference between them if everyone was starting from the same general rules of styling. And so we want these to be shareable. We want these to be able to be used as a template, essentially very similar to how a PowerPoint slideshow template would be used. That might be simplifying it a little bit too much, but you get the general idea of, we want this to be able to help our users be more uniform and make presentations better. And the final component, I guess, going back to making it easy, we want, like, I don't, maybe this is not a shared experience, but in my experience, there's, maybe you're editing your slides the day before your big lab presentation, right? Or giving a presentation to someone else. We want you to be able to create good looking images or, you know, compelling structures as quickly as possible. Just a couple clicks and you'll be able to have something that's presentable in a reasonable fashion. We don't want you having to run 40 different scripts and make all these little changes. Like, you can if you want to, but we want it to be much easier than that. So with all that in mind, I'm going to be starting a little demo in this next segment and try to get away from just presenting slides. So first, I'm going to review how presets are currently implemented in PyMOL, and then I'm going to move on to what the new preset panel is going to look like and how it's going to function. And just right off the top, I'm going to give the disclaimer: this is still very, very, very much under active development. I'm changing things daily and have like 4 different versions of it right now. So if anything breaks, please excuse the lack of professionalism, but yeah, I'm hoping everything should be smooth. So after I kind of give you a general overview of the presets panel, we're going to pause and have some time for discussion on that. And then we're going to create our own preset. And then finally, I kind of want to open the floor to more general questions about, like, what would be the most helpful in terms of what could be added to this. So for instance, well, we'll get into it, but you might have a very particular thing that would be very helpful for your kind of presets. It's very helpful for me to know that. I mean, we are essentially trying to reach out and learn about people's workflows so that we can make this as good as possible before we release it. So all that being said, I'm now going to switch over to PyMOL. Hopefully this is smooth. All right, cool. So should now be able to see PyMOL. Hopefully it's all good.
Looks
awesome.
good.
Thank you. So this is actually the structure that I've been talking so much about, this Cas9 with its peptide inhibitor. This is how it's loaded in by default. So let's go through and review how presets currently work in PyMOL. So currently, they're relatively varied and not very front-facing, but you would click the action menu, go down to preset, and then pick from these whichever one you would want. So let's do, I don't know, ball and stick or something that's going to be unique. Here's ball and stick. I don't know how helpful that is, but it shows it in a very different representation than the default load in. Simple, I think, is even less helpful. It makes a cool looking image, but again, these are good at creating things that look distinct and unique, but in terms of how helpful they actually are as a starting point, I don't know anybody that's going to be using this preset as a actual presentation image, right? Again, look cool, but how helpful are they actually? Furthermore, if we look at like publication, for instance, this is a, quite frankly, outdated view of what a publication image would look like. I would be surprised to see this in a current journal, but back when this was created, this was much more standard or normal, I guess. So with all that in mind, let me go back to actually we'll do something better than that. Pretty maybe, pretty is fine. We'll use this as our starting point. This is, again, how helpful is this? It looks really cool, but how helpful is it really? I don't know. So without further ado, let me introduce you to the new presets panel and what that actually looks like. So this is what the panel looks like. So you can see on the left, we have some actually very familiar names from the presets I just showed you, but now implemented in a completely different way. Currently, this is well, actually, let me show you fancy initially, or simple is actually probably a better way of doing it. These are meant to mimic the presets that currently exist and offer very similar, distinct styles. I think these are slightly more updated, but still meant to be very general, very, I don't know, like not used in any kind of technical way. But if we look more towards the bottom, we get into some more technical presets that I've made personally. So let me actually show you one of my favorites. I will get rid of this structure and load in a antibody. So this is how antibodies are, or I guess all proteins are loaded in by default. Not very helpful, but if we load the biologics preset that I made, and give it a second, it will show you. This is initially maybe a little bit overwhelming, but like, let's say you are a student that's new to learning about what antibody structure looks like. This preset would be used to highlight some of the key areas. So for instance, we can see our binding region, and they're showing a surface and it's colored by atom, so you can get an idea of the charge of the binding regions. But more importantly, we're also colored by chain, right? So we can see the difference between our heavy and light chains. And also, if you look very closely, and I'll zoom in on this, we're showing our disulfide bonds as sticks, showing what's actually holding this structure together. And we also have the organic or polysaccharide components shown as sticks as well, but colored slightly differently than the disulfides. So again, this is meant to kind of demonstrate a list of changes or representations that are meant to give a little more information and a little more purpose to the preset rather than just being a general styling. So I'll actually use this biologics preset to show you some of the editing options, and then I'll show off a couple different other structures with their particular presets, and then we'll get into maybe creating our own as well. So as you can see from this menu, we have the option of adding new presets, editing ones that already exist, deleting, import, export, everything you would expect. For now, we're just going to look at editing them. So when we press edit, it opens up this edit menu. Initially, it can be a little overwhelming, but I promise it actually makes a lot of sense in how it's laid out. Up at the top, you can see we are editing the biologics preset. And on the left, we have all of our selections listed and checkboxes to indicate which ones are actually active or have rules being applied to them. So for instance, I'll show, well, actually, it doesn't really matter, but all will have a particular set of rules. So let's look at all real quick. When you make a selection within the selections table, I guess, it will populate this right-hand side with all the options for that selection. So you can see the selection string that's being used to make a selection. All is all, pretty simple. The representations that are going to be applied, any kind of coloring that's going to be applied, any settings you want to have be applied to that particular selection, and then any additional commands that should be run. We're still working out how this should actually be implemented, but for now, it's just like running any other script, but it's meant to give, again, as I mentioned before, empowering our power users. If you have particular commands that you want to run, this is the best place for that. So this is a very basic selection, but let's look at something more interesting, right? Let's look at our binding regions. So this is extremely not technical. I am just doing this to show off something cool. But currently how these are being selected are from this top disulfide bond in the middle. Anything within 70 angstroms is anything within 70 angstroms is excluded. Sorry, the selection string logic can get a little complicated, but yeah, so essentially that's how I'm creating these outer surface areas, is anything that's further than 70 angstroms away is being selected. Again, not technical, not trying to say that's how any of this actually works, but as a demonstration. So you can see within these regions, though, we're going to be showing our sticks and our surface, and then coloring by element with a custom kind of like teal color that I think looks good. And then we're going to be setting our transparency of that surface to be 50% or 0.5, so that we can actually see through and see some of the residues there. You have the ability to add additional settings if you'd like, but that's a general overview of everything you can edit. So with that, let me actually show you a different structure that will show you an even more technically oriented preset. Let me load this in real quick. So this is a example of a smaller peptide or smaller protein with just a single organic ligand, and how it's by default loaded in. So with that in mind, this is good at showing the overall structure, but let's say that we want to understand, well, how does this ligand actually bind? What does this binding site look like? So we'll open up our presets menu and then go to, for instance, small molecule binding. This is another one I've created. And so this is a far more technical preset. Like I said, this is not meant to be a general one. This is for particularly small molecule binding. But you can see we're actually zooming in and characterizing this binding site immediately, one click. Boom, you can see how something's bound. You can get distances and interactions, get an idea of what the binding pocket looks like, and also zoom in on it, right? So like really, really focus on something within the larger structure. And I mean, you might have to play around with it a little bit, but that's almost ready for a slideshow or ready for any kind of presentation or publication or whatever. And that was just with a single click. So how do we create that? So we'll go back to our edit menu. And so you can see that this one is a little more complicated. This one's got some additional selections that I've defined, the binding site and the binding site with the ligand. And you can see, sorry, I guess I shouldn't be covering it all up. For the binding site in particular, we're showing the surface and these wire representations. We're not doing any coloring, we're doing the same 50% transparency. And then for the binding site with the ligand, we have these additional commands that we're running down here where we're calculating these polar contacts and then zooming in on the ligand itself. So that's an example. And well, actually here, this is also important. Creating this binding site is done by selecting all within a certain distance cutoff of anything labeled organic. So in some of the larger structures, they have multiple compounds, so you get multiple different binding sites like this, but that's just a normal PyMOL selection string that works like any other selection string in PyMOL, but now applied to this like preset stylization. So with that, I think actually I'm going to pause here real quick for any kind of questions, since I just threw a ton of information at you. And for any questions on how this works, what the current capabilities are, anything in that vein. So I'll pause for that real quick.
Yep. And just process-wise, if you have a question, you could either send them to one of the hosts in chat or raise your hand and we will unmute you. I think if we're going to have a conversation, raising your hand is probably the way to go. And if there are no hands, I've already got a stack of questions I'm happy to ask, but I don't want to monopolize things. So please, I will start. And if folks have questions, please raise your hands and we will unmute you. So I guess in maybe the first one is you'd mentioned presets for sharing them. Have you given some thought, like if somebody says, all right, I created a preset, I'd like to give it to my lab members or put it up on the PyMOL wiki. Is that going to be like a PML script, a PSE, still to be determined?
I am quite literally writing that code like today and yesterday. So that's what we're kind of still settling on. But the two examples that you just gave are exactly what we're trying to target. We're trying to be able to have this be emailed to your lab mates or serve as a template. And then also probably have some kind of public repository where people can upload the really, really cool ones that they create. Currently, I'm doing everything through JSON format, but I feel like there's certain formats that might be easier to understand and easier to pass around to people than that. I don't know, we haven't quite landed on a solution to that, but that's kind of the general thinking that we're currently doing.
YAML might be worth a look if you haven't looked, if it's probably on your list already, but.
Yes, it is. But again, it's like you're trying to balance making it easy for people to use and control on our side, because we don't, how do you handle people being able to select any file? I don't know, that's what we're working through right now.
Yeah. All right, so we've got two questions from other people. So Maria Font, I will see if I can unmute you.
Awesome.
All right.
Hi. So I think your ligand binding site preset is really, really cool. And I was just curious if this is this is something PyMOL can do right now, or if this is something you're going to add, which is just to map like hydrophobic contacts, or like if you had a pocket that had a lot of hydrophobic interaction that was important for the binding site, is that something you can map? Is that something you're thinking about including as an ability to map?
So that's definitely, I would say it's definitely possible in PyMOL right now, just like almost anything else in that vein would be possible through scripting, right? But that's really what we're trying to achieve with these presets, is that you wouldn't need to run some crazy long script or create your own script to be able to do that kind of stuff. So that's one example of like, that's not really implemented right now, but that would be a great preset for us to be able to have as a default even, being able to map. I mean, because that's ultimately, I can think of a whole bunch of different use cases for that, but that's what a lot of people are interested in, right? They're interested in how things are binding. They're interested in characterizing either binding pockets or larger protein-protein interactions, right? And that's going to be a core component of it. So that, I guess, I don't know if that answers your question, but that is exactly the kind of stuff that we're trying to target with these presets eventually. We're not quite there yet, but eventually that will be one of the main ones, hopefully.
Awesome. Yeah, cool. Thank you.
You're welcome.
So we've got a question from Diego Del Olmo. I apologize if I'm pronouncing that wrong. Will there be a way to use custom color schemes for gradients, such as Viridis? I'm probably pronouncing wrong also.
Yeah, so generally, custom, so that's another component. Actually, I'll show that maybe in a little bit when we're creating our own. But currently, you're able to completely customize color now, which is not previously how PyMOL has worked. PyMOL has worked on a set of predefined color, they're not swatches, but like color spectrums that are like enumerated and defined. We're trying to get away from that. We're trying to get closer to being able to use a spectrum of hex values if that's what you want, or whatever. Being able to pick your own colors though, because particularly I personally am red-green colorblind. So there's certain color schemes that really are awful. And I would like to be able to define my own that are more appealing to my eyes, I guess. So that's particularly an area that I am personally sensitive to. And since I'm getting to shape this, I'm making sure that's like kind of at the forefront of being able to customize your own color palette.
I am glad that you are, because I have family who are also red-green colorblind, and that's not an issue in software a lot.
Right, yes.
All right, and so we've got another question from Rachel Gaudet.
Hey, I think this is an exciting development, and I guess piggybacking on Pete's question, I guess for me, what would be useful is if the output is then editable outside of this GUI, right? So that if you want to, propagate this, but have like 5 different structures where that, central residue is a different number, that you don't have to like go into the GUI every time to change it. But I guess that's what I would say. I'm pretty agnostic as to what actual language is in, other than it would be nice for it to be then editable from the script rather than from the GUI.
No, definitely. And that's why I'm currently experimenting with just a TXT file, because then you can edit that however. You don't have to have any kind of fancy software, or you just need a basic text editor for that. I think that's definitely the end goal, is that you will be able to make modifications without having to go through all these steps to get to the, the 4th selection that you've created and all that. The other idea that we were experimenting with originally was that this would automatically generate a script, like a full PML script that you would be able to customize, but even beyond that, pass around to other people and just have them run it as a normal script and run the normal commands. That may still be on the table. I don't think that's going to be in the first implementation, because that's a little bit harder to obviously do and translate everything properly. But that's kind of the 2 ways in which we might go about that. But yeah, I think the initial version of this is going to have at least some ability to export a text TXT document that you would be able to edit quite easily. Because like you said, a lot of times you're going to be making smaller modifications, like you said, to like some particular selection or some particular name, right? And we want that to be as easy as possible. So definitely, it's good to hear, though. I'm glad that my assumption is being kind of like, I don't know, confirmed.
All right. One 2-part question. So more on the subject of, presets to start with than building your own presets, but have you given any thought to a preset for structures where there are partial occupancies or there's a large B factor range? And tying into that, what about electron density?
Right.
And I ask about electron density in particular because I know that PyMOL is awesome for making figures of electron density, and I know that that's an area there you can get great results, but it also takes it can take a lot of time.
It can take some elbow grease for sure. Yeah, so that's another case that I haven't experimented with, but is kind of the general target of what we're trying to get at, right? So it's those things that are normally very, like you said, it takes like a bunch of steps to just get to your base image that you would want to make every single time anyway, right? So that's definitely one of the ones that we should add. I've not done that yet, but I will definitely add that to my to-do list of presets to look into. And well, I might be in contact with you maybe on what would be the most helpful as a starting preset for that, right? Like I have good intuition on what looks cool, but it should really be up to the experts in terms of like what's like technically correct as a starting point. We don't want to be misrepresenting structures as a default, right?
Yeah. I'd always be happy to answer questions. And I think like you'd mentioned the educational thing, and one thing that I've encountered and heard of from educational is you look at the structure in PyMOL and they think everything that's modeled is there, but then they click on it and the occupancy is 0. So
right.
That's an area where the visualization experts, I am sure, would have good insight.
Yeah, and I think there's always that moment in a like biochemistry student's journey where they kind of start realizing that structure is less defined than it's kind of implied initially, if that makes sense. Like,
yeah,
I don't know how else to put that, but like, this little loop region that you see looping out very far from the protein, that's probably not actually like indicative of what its normal state is, or it's constantly going to be in flux. So, I mean, I don't know. Yeah, but that gets into
there's limits to how much of a tool can solve that. I think it's just PyMOL is used so much for education that it's going to be something coming up.
Right, but for instance, for that case, maybe we look into having a different coloring scheme so you can kind of indicate which regions are less structurally sound or something. You know what I mean? Like, I don't know exactly what that would look like yet, but those are the kind of things that we want to move towards. For instance, I guess I might show this when we're creating our own preset, but one of the coloring options is for coloring by secondary structure. And how helpful that is in a technical sense, I don't know, but in an educational sense, that's huge, right? Being able to see how like a larger protein is made up of these, like I'm trying to think of a good example, but like some kind of like beta barrel, membrane protein. That's a great example of where secondary structure isn't immediately obvious, but maybe when you color by these different regions, you can see how things are like there's a loop that goes all the way around the protein or something like that. I'm nerding out a little bit too much about that, but you get the general idea.
I do, and you're actually transitioning pretty well to the next question, which we've got from Elaine Tai. And currently, PyMOL can identify and represent alpha helixes and beta sheets. Will it be able to identify interchain hydrogen bonds in the future?
So, well, that's actually another a totally separate thing that we're looking into currently. So I'm trying to remember exactly how the hydrogen bonding code works. Some of it is fairly naive and distance-based, or just a simple distance-based with a simple lookup of, would these two things be hydrogen bound to each other? But that's something we're investigating in terms of more accurately representing hydrogen bonds in general and making sure that we don't misrepresent that kind of stuff. But for right now, I'm pretty sure you're able to show those kind of interactions based purely on distance and like atom type. But it gets a little more dicey when you get into more complicated structures that, it might over-represent some of the hydrogen bonding or under-represent. Just with a simple distance cutoff, it's kind of hard to accurately represent that. But, and I don't want to ramble too long on this, but then you get into larger questions of like, okay, well, what is technically hydrogen bonding? When you get into very technical cases, the consensus on what actually is correct kind of breaks down a little bit. So I don't want to ramble more on that, but you get the general idea.
Yeah, it does have hidden depths sometimes. But... All right, I think that's run through all the questions that people have come up with so far. So I may have one very last one. Have you given any thought to electrostatic surfaces and presets? Yes. And I was reminded of that from your binding site diagram, or your binding site preset.
So particularly with electrostatics, that's actually
that's probably another area where there's hidden depths. But.
Right. Well, not only is there hidden depth, but we want to improve PyMOL's ability to represent electrostatics in general. Not that currently it's good at representing some of the stuff, but it's not as easy as we would want it to be. Particularly, you can kind of tell that's what I've been talking about over and over again. We want this to be as easy as possible, especially to new people. But we want to, I guess, improve that separately from this, and then also integrate that into the preset. So that would be a additional, set baseline preset. And I guess furthermore on that, like that's part of why I want to get feedback from the audience now, is what would be the most helpful of these base presets. I think we've already identified a couple that I haven't thought of that would be helpful. But yeah, that's kind of what we're trying to determine at this stage, is like, what is the most helpful for base presets or base selections, and then move on from there in terms of like how specific is this actually going to be, or how generally desired is it, I guess.
Great.
Cool.
Thank you. So I think we've now run through the list of questions that have come in so far. So.
Awesome. Any other questions before we move on in the chat or anything? Because I'm gonna make a custom preset real quick, and actually I'll probably show off some of the other ones.
Actually, so not a question, but during your intro you'd mentioned the integration with the other Schrödinger tools in PyMOL. And my note for that is I've used that. It feels like it's awesome. So it is, from a non-developer, I really appreciate having that there, and it works very well.
Yeah, no, definitely. And I mean, I'm not trying to be a salesperson for the whole Schrödinger suite or anything, but that's one of the advantages of PyMOL in general, is that you have that option if you choose to start using some other products in the future. If you use some of the other visualization tools, that's just not an option because it's not part of the same family or software suite, I guess. And we're working even to further improve that now. That's another major focus. I feel like we've hit on all the major things that we want PyMOL to be able to do today. But yeah, so with that, let me load in a couple other structures. I have some prepared. Also, I'll use this to highlight key bindings. I don't know if this is another thing I worked on in the previous update, but you can set custom keyboard shortcuts. And I made this whole menu that lays out what all the keyboard shortcuts do. But I personally have, what do I have that's important? These last three are my user-defined presets. I have Control R as reinitialize. I have Control D that makes some scenes, and Control V that loads in a biologic structure. So I can just, Control B, boom, I got my whatever structure I want. That's just a side note that I think is cool. But for now, let me actually load in, I'll load in that smaller structure. I think that'll be easier to use. Yeah, the one easy. Yeah. Okay, so how would we actually go about creating a structure, and what does that look like? I've undocked my GUI. Okay. So this was the one that we demonstrated, the small molecule binding, but let's actually make a new one. So we'll do, I don't know, SBGrid, create a new preset. And when you initially create it, it starts with nothing currently being selected. Sorry, I keep hiding it. So we have all these base selections, but nothing is currently active. And you can see these line up roughly with the current PyMOL selection logic. So we have selection logic for polymer, protein, and you can read all of them here. But we also have the ability to add our own, right? So let's actually, here, I'll create a new preset. So here you would enter the name of whatever new selection you want to have. Let's say binding pocket, and the selection string that's going to be used to create that. So we'll do all within 3.6 or something of organic. So this will use the organic selection, expand it out 3.6 and go from there. And let's just see what that does first. We'll do cartoon for all. And then in this one, we will do sticks. And we'll save that. So currently, I have to click this. And that should be save, apply. Why is that not showing now? Welcome to the fun part of early development. Let me back out of this. Our binding selection logic. So if we do by res, you can see you can essentially create your own fully customized selection strings that should. Yeah, I'm having some issues with that. It might be a problem with this build, but what I will do instead is show off some of the other cool presets. So let's load back in our initial structure, and I will highlight the, we already saw small molecule binding, but let's take another look at it in a larger structure. So you can see, we can cycle through the different ligands. It looks very similar, but in this larger structure, the context is kind of changed, right? So you can get this like zoomed out view and get an idea of where the ligands are located in the larger structure, but then also obviously zoom in and see the same view that we saw before. But let's look at the protein-protein interactions, for instance. So as I mentioned previously, this is a peptide inhibitor of Cas9. So you might be quite interested in the protein-protein interactions for that. And you can see here, we're showing this kind of like phantom surface and not actually labeling any interactions on this particular one, but you still get a general sense of how these two proteins are interacting. And I'm pretty sure I have a separate, I thought I had a separate peptide inhibitor. Maybe I do not. I guess I don't. Oh, actually, hold on. I want to show a completely different style. So like I mentioned before at the beginning of my presentation, we have the ability to create some more complicated or more complex styles that people otherwise aren't going to do, right? The previous presets that I've shown you have all kind of been traditional PyMOL stylings. But like, let's take a look at, what would be a good example? Well, this one for sure. This looks completely different. This is the one that I said I really, really liked, but we can just ray trace this real quick and you get a completely alien looking molecule for PyMOL. But let's look at, where's the stylized? Yeah. So this one, this is very, very good for showing off small molecules, for instance. So like, let's say, I mean, I don't want to be, assume anything, but like, let's say you worked at a pharma company, for instance, and you were interested in making a little movie to show off your, the drug that you're working on. You could apply this preset, zoom in, save this as a scene, and then, you know, transition in your movie to your next preset, which would be small molecule binding. Boom, there you go. And kind of like allow this structure to evolve through these different presets and show completely different stylings, but hopefully gain some information from it, right? Yeah, I think that's most of kind of what I want to show off. And as I mentioned, this is all very, very much so under active development. So it might look different in the final implementation, but yeah. So are there any other questions about this first? And then if we don't have any questions about presets, if anyone has any general PyMOL questions or qualms, now is the time to ask them.
So I have not seen any preset related questions. We do have one general one that's come in.
Okay.
And also one thing to mention is live demo. That's very brave. It's worked well. I have generally always tended towards I'm going to record a movie just in case. So, all right. So we've had the question I mentioned came in from Eric Nunez Aguilar. I apologize for butchering everybody's last names. And is there a way to overlay the tray or pin it so it doesn't get taken out of the window? And this is kind of a three-parter. When building, are there similarities to how Coot builds proteins molecules, or are there ways to import smiles and then use those directly in PyMOL?
Yes. Okay. So first with the overlay, there definitely is. That's one of the other things I'm experimenting with, is how this window should interact with the larger window. On Mac, things behave a little more uniquely, I would say, just because when you're in full screen, Mac likes to literally take your entire screen, so it behaves a little more strangely. But yeah, so there's certain what I'm thinking is going to happen is that this is going to have the like uppermost focus, and even if you click in the window, it won't be hidden away like it is in the current implementation. But yeah, it should be stuck on top, and then the edit menu should be on top of that, if that makes sense. And then there's even some other like editing a name menu that should be on top of that. like I said, all under active development, so that's not implemented yet, but that is on the list of to do. The second component of that, I don't remember what the first part of it was, but for implementing the like smile type objects, that's definitely possible. I've done that personally, and I made a whole other little script for that actually. Yeah, that's definitely possible and relatively easy to do. I'm pretty sure there's I want to say there's a wiki page on that. If not, I can look into it further and try to get back to them. But yeah.
All right. Well, thank you. And we have, Serrano mentioned he had some questions, so I will track him down and unmute him. All right, Serrano.
Hi, Thomas. That was nice.
Thank you.
This is just a general question, not so much about the presets. I tend to use the command line. I wasn't able to find a way to change the settings differentially. Like, for example, when we change the settings to label size or font size, it's all the labels are changed. Is there some way to selectively change them?
Yes, definitely. So the actual CMD set command, I'm pretty sure that's what it is. One of the optional arguments is a selection within that. Not all settings respect that selection argument, but many do. That's one thing that I've found when working on the presets panel, actually. I'm pretty sure, I want to say label size does respect the selection, but there's particular other things that are more rendering focused, I guess, like shadows or ambient occlusion or something. That does not.
Or like sphere size. Can we have some waters small sphere and other waters larger spheres?
I don't know that if that is possible, you can use that selection and it should work. But I don't know particularly about like sphere size, because that is a CGO related setting, so that might be global.
Or stick size, stick thickness. Yeah. That's a very common request, but I can't selectively change the thickness of sticks.
Yeah. Have you tried it with the selection argument or no?
I'm not sure I know what you refer to, but maybe maybe you could email me something.
Yeah. Afterwards. Yeah, no, definitely.
And there was just one more question I had, which was it's a bit esoteric, which is to align small molecules. It's a little difficult to do that with PyMOL, but it is sometimes very useful. Like even like aligning ATP is very difficult to do that here. Do you know if there's any effort along that front?
Yeah, so that's yet another thing that we'd like to improve. I feel like we have so many things we want PyMOL to do better, but yeah, that's definitely an area of focus. Particularly, there's some other internal stuff that's driving that. We want to improve in general, but particularly when there's a concrete reason to, that usually gets done a little bit faster, obviously. But yeah, we're definitely going to look into that. But that, I mean, again, that gets into kind of what we were talking about before about like what the right answer is. Particularly, there's obviously small molecules a little bit different, but with larger structures, what like the correct alignment is, it depends on some algorithm, right? And you have to pick what you want that to be. So we'll have to do some more work into determining like what algorithm we want to use and implement, and if we need to create our own or not. Yeah, that might take a while, but that definitely is on our radar of things we want to improve as well.
Great, thank you.
You're welcome.
And one suggestion that's come in from Harman Zokola is, how about a preset to force symmetry generation to pack the cell?
That, yeah, I actually haven't even thought about that. I know we did a I guess it's been almost a year, but we were working on some other issues with how objects behaved within the cell, and particularly crossing the boundaries. And we're trying to come up with a way of filling the cell accurately and automatically. I don't know where that went, but this is, yeah, that's yet another great example of like a preset that would be awesome for a crystallographer to have as a default. But like, I feel like I kind of keep saying that, but like this highlights yet another case of like being very, I don't want to say niche, but like department dependent. So like within your department, you might want to have a, hey, this is how we load in crystal files initially when we're going to be discussing the crystallization results or something like that. That might be an example of one that's more too specific to include in general, but would be very, very helpful to a particular subset within the field for sure.
Yeah, a crystallographer, that would be great for somebody interpreting the binding site for a small molecule binding. Not really relevant unless it's packing in there. So yeah.
Right, exactly.
When you've got a large user base, you've got to balance, you've got to be flexible.
Right. Well, and that's where hopefully the, like, whatever the public forum for this ends up being, either the wiki or something along those lines, that will be an option where you can, you know, the crystallographers can be like, oh, hey, I made this really cool preset, and then lots of people can use it then. And that takes a little bit more work off of our shoulders and puts it in the hands of the experts. But yeah, hopefully that's what I'm focused on now, is creating the tools so that others can do that kind of work, hopefully.
We've got two more comment suggestions that came in. So one from Janet Smith, that it would be great to display fewer symmetry mates or make it selectable sometimes. And another from Sandra Gabelli, and thank you for presenting, and exporting the presets as scripts would be awesome, as Rachel suggested. So
definitely. So yeah, so I think
the chat.
Yeah, I think ultimately, well, this is kind of highlighted that there kind of should be several different options, and that's very helpful for me as I'm developing it. This might be something that changes over time as well. So we don't know when PyMOL 3.0 will be released, or fully what will even be included in that. But once it is, it will obviously still be under development. And, we might, if we get a lot of requests for, hey, I want to have this feature added, that's definitely on the table. And people should feel free to voice their opinions on what would be the most helpful, right? Because ultimately, that's why we're doing all this in the first place, is to make it easy and helpful for our users, right? So the more feedback that we can get on that kind of stuff, the easier it will be for us to do our job in that sense.
And it's great to have that you guys are open to feedback on things like this. If people have suggestions, and you're going out there and trying to find them, which
exactly
makes everybody's lives work more smoothly. All right, we're starting to come up on the end of the hour. So if anybody has any questions in a minute, now is the time. And if not, then Thomas, once again, thank you for joining us and for presenting and answering all of our questions and having a live demo. That's
of course. Thank you everyone for listening.